So what I like about this question is that we're unable to integrate or differentiate trig when it's not in the correct form. And what do I mean by that? If we have a form where we only have one function, so I can only do it one at a time, and it'll look something like this, we're happy. So I could, if I wanted, I could differentiate sine cubed, I could differentiate cos cubed, things like that. I could differentiate this where the bracket's got a number in, but I can't differentiate sine x, cos x together. I can't do that. So we need it to be in this nice kind of standard form. Otherwise, it starts to break down. So you notice this question is a bit of an outlier. Some people might think, well, wait a minute, I can just do it outside the bracket and then times by differential. It doesn't work like that. We have to express it in that nice form in order that we can differentiate or integrate. Okay, so that's your clue here, that you're not just using the chain rule or reverse chain rule, whatever. Okay, so the first thing we're going to do is break that out. And again, people are going to get all stressed out and they're going to make silly mistakes. This we need to use our box method for. So I've got, computer's going to whistle, sine squared x. I've got positive cos squared x because two negatives make it positive. Then I've got negative sine x cos x. And then I've got negative sine x cos x again. So what does that give me? Well, it gives me sine squared x plus cos squared x plus 2, or sorry, take away 2 sine x cos x. Now we know that sine x squared plus cos x squared gives us 1, so that's just going to be 1. And this is our identity that we're given in the front of the booklet, negative 2 sine x cos x. Whenever you get these, it's maybe worth just having a wee look at your writing down some of the formulae. But that becomes sine 2x. I wonder if I can just find it. Is it here? Yep. It'd be worth maybe just writing down a few of them when you get a question like this, just to remind you of what you've got. But you have to remember this is 1, and you also have to remember that sine over cos is tan. Okay, but yeah, I've just changed this to sine x cos x to sine 2x. So again, before, those can be tricky questions, the kind of proof ones, and annoyingly, there's not a way of missing that one out, and if you have to do this to the second one. But what it's saying now, okay, if we want to integrate this, I'm going to integrate the function which I can integrate. I can integrate this. That is in the correct form for integration because it is. I'll just copy and paste it. It is in the right form. Here, that will just pop up in a little second. Yes, it's in the right form. So now I can integrate. Instead of integrating the bracket they said, I'm going to integrate 1 take away sine 2x with respect to x. So what happens when I integrate 1? Well, I'm going to get x. And now, let's have a look. What happens when I integrate sine? Well, again, I would always write sine when I differentiate it becomes cos, which when I differentiate it is negative sine, which then is negative cos. So that's differentiation. Why the computer's going so slow now? Maybe I'm getting really fast. Let's see, so sine, technically I've got negative sine, but it doesn't really matter. Okay, I'll say I've got negative sine. So there's negative sine, integrate that becomes cos. So that negative sine is going to become positive cos 2x. And I've got my plus c, But what do I have to do as well? What does this say? I have to divide by the differential as well. So I'm going to have to divide this by the 2. And then simply, I'll just tidy that up with x plus 1/2 cos 2x plus c. And that's u. So this question I liked because it's making you think again about some of the identities, but also it's getting you thinking about what you can actually integrate and differentiate. Yeah, you want it to be in a suitable form. Okay, we couldn't integrate that using reverse chain rule. Okay, so Hope that's helpful, and yeah, nearly finished.